Hi guys, in this video we're going to learn about descriptive statistics. What is descriptive statistics? So descriptive statistics is branch of statistics that involves summarizing, organizing, and presenting data meaningfully and concisely. One more time, descriptive statistics is branch of statistics that involves summarizing, organizing, and presenting data meaningfully and concisely. It helps you to summarize and understand the key features of dataset without getting too complicated. By using descriptive statistics, we can gain valuable insight into patterns, trends, and distribution within the data, allowing us to make informed decisions. In general, descriptive statistics simplify complex data by presenting it in easy-to-understand format like graph, table, and summary measure. Now, there are two measures of descriptive statistics. The first one is measure of central tendency. The second one is measure of dispersion or variability. Let's talk it one by one. Central tendency. Central tendency is a method used to describe the center or typical value of dataset. For example, I have this dataset 3, 9, 6, 7, 8, 6. Now we want to measure the central tendency. The first one is mean. Mean is the average value of the dataset. It is easy, just sum all the data divided by the number of the data. So we find the sum of 3, 9, 6, 7, 8, 6 divided by the number of the data, which is 6. So the total will be 39 divided by 6. It equals to 6.5. So the average or the mean of the data set is 6.5. By the way guys, I would like to inform you about the symbol. If the data is population, so the population mean is symbolized with mu, while for the sample mean is symbolized with x bar. The second one is the mode. What is mode? Mode is the value that appears most frequently in a data set. In this data, 6 appears twice, while the other appears once. It means 6 appears most frequently in this data set, so 6 is the mode. Now let's find the median and quartile. To find the median and quartile, we have to sort the data ascendingly first. Median is the middle value. Quartile means we divide the dataset into 4 equal parts. There will be 3 types of quartile. The first one is lower quartile or the first quartile. It represents the value below which 25% of the data points fall. The second one is middle quartile or the second quartile. It represents the value which 50% of the data points falls. It is the median. So middle quartile or 50% percentile, it is median. The third one is upper quartile or the third quartile. The upper quartile represents the value below which 75% of the data points fall. Again, to find the median and also quartile, you have to sort the data set ascendingly. Okay, let's use the previous data set. We have to sort the data set ascendingly first. So it will be 3, 6, 6, 7, 8, 9. There are 6 data. So the median is the middle value. Since we have 6 data, the middle value will be located between the third and also fourth data. The third data is 6, the fourth data is 7. So the median will be 6 plus 7 divided by 2. It will be 6.5. So the median or the middle quartile or the second quartile is 6.5. To find the lower quartile, we find the middle value of lower half data. Lower half data is the data before the median. The data before median is 3, 6, and 6. So the middle of this data is 6, since 6 is located in the second position. So the lower quartile or the first quartile will be 6. How about the upper quartile? Upper quartile is the value of the higher half data. Higher half data is the data after median. It is 7, 8, and 9. The middle value is 8. So 8 will be the upper quartile or the third quartile. There is we call as interquartile range. Interquartile range is the third quartile minus the first quartile. In this case, it is 8 minus 6. It equals to 2. Now, how if the number of data set is odd, not even? For example, 3, 5, 6, 7, 7. So the middle value is in the third position. Since the number of the data is 5, so the middle value is in the third position, directly 6. So the median is 6. How about the lower quartile? It is the middle value of 3 and 5. So the lower quartile will be the average between 3 and 5. It is 3 plus 5 divided by 2. It equals to 4. How about the upper quartile? It is the middle value of higher half data. We need to find the middle value between 7 and also 7. So 7 plus 7 divided by 2, it equals to 7. Is it easy, right? For mean, median, and mode, we can calculate directly using Microsoft Excel. For quartile, actually there is formula of quartile in Microsoft Excel, but I think the result is still not accurate. So let's try to find mean, median, mode in Microsoft Excel. So we use the same data, 3, 6, 6, 7, 8, 9. Then we find the mean, just equals, then average, then we choose the data. Okay, P2 up to P7, close bracket and enter. The mean is 6.5 like previously what we have calculated. Median equals median and then find the data. Okay, close bracket, enter. The median is 6.5 like what we have calculated before as well. For the mode, equals to mode, open bracket, the data, close bracket, and enter. The mode is 6 like what we have calculated before as well. By the way guys, the mean that we have learned previously is called as arithmetic mean. There are the other mean we call as geometric mean. What is the difference? Arithmetic mean is good to find the general average, while geometric mean is useful in finding the average change of percentage, ratio, index, or growth rate over time. So, if the data is in the form of percentage, ratio, index, or growth rate, it's better for us to use geometric means because it can dampen the effect of outliers. This is the formula of geometric means. Geometric mean formula is the nth root of the multiplication of the data. So, for example, suppose you receive a 5% increase in salary this year and 15% increase next year. So you are asked to find the geometric mean. 5% increase means 105% because the 5% is only the increase. So 100% plus 5% equals to 105% or 1.05. 15% increase, it means 115%. So don't forget to add it with 100% if it is the increase. 115% equals to 1.15. So to find the geometric mean, the formula will be the nth root of the multiplication of the data. Since there are two data, it means the square root of the x1 and also x2. The x1 is 1.05, the x2 will be 1.15. So the result will be 1.09886 or 109.886%. If we are asked the increase, just deduct with 100% or with 1. So it equals to 1.09886 minus 1. It equals to 0.09886 or 9.886%. The other application of geometric mean is to find an average percentage change over a period of time. For example, if you earn $45,000 in 2006 and $100,000 in 2018, and you are asked what is your annual rate of increase over the period. So you can use this formula. Geometric mean is the nth root of value at the end of the period divided by value at start of period minus 1. Value at the end of period is the value in 2018, it is 100,000 US dollar, divided by value at start of period is $45,000. And the end is the difference of time. It means 2018 minus 2006. It is 12. The result will be 6.88%. The second one is measure of dispersion. Imagine you have a group of friends who all have different heights. Some might be very close in height to each other, while others might be much taller or shorter. A measure of dispersion helps you understand how spread out these heights are. If most of your friends are around the same height, the dispersion is low. But if some are very tall or others very short, the dispersion is high. So basically, dispersion tells us about variability and risk. If the data points in a dataset are spread out widely, it indicates high variability, which means there is more risk or uncertainty associated with predicting future outcomes based on the data. Conversely, if the data points are tightly clustered together, it indicates lower variability and less risk of uncertainty in prediction. There are several measurements that we can use. Range, it is the largest value or maximum value minus smallest value or minimum value. Mean deviation, variance, and also standard deviation. So standard deviation is the square root of the variance. For calculating variance and standard deviation, you have to pay attention whether it is population or sample, since the formula will be different. This is the formula of variance and standard deviation of population. And this is the formula of variance and standard deviation of the sample. The difference is in the denominator. For the population, the denominator is n, while for the sample, the denominator is n minus 1. To make it easier, we can find the range, mean deviation, variance, and standard deviation in Microsoft Excel. The first one is range. As we know that range formula is largest value minus smallest value. So we need to find the maximum value and also minimum value. For maximum value formula equals to max and also the data. We can find the maximum value is 9. How about the minimum value equals to mean, open bracket, and the data, close bracket, 3. So the range equals to maximum value minus minimum value. It will be 6. Now we need to find mean deviation. There is no direct formula to find mean deviation. So we have to calculate it manually, but using the Excel formula as well. The formula of mean deviation is sigma, the absolute of x minus x bar divided by n. X bar is the average, so the x bar is 6.5. So we need to list the data first, 3, 6, 6, 7, 8, 9 here. And then we find first the absolute of x minus x bar. The formula will be equals absolute ABS, open bracket, x, this is 3, minus the x bar is the mean 6.5, but we have to make it as absolute because we want to lock the cell, because all the mean will be the same, right? Close bracket, enter. Okay, then we pull the formula down. Okay, after that we sum all this all. Okay, we sum all this all. The sum is 9. 9 is the sigma of absolute of x minus x bar. However, the formula of mean deviation is sigma absolute of x minus x bar divided by n. So the mean deviation is this 9 divided by the n. N is number of data. It is 6. So the mean deviation will be 1.5. Now we will try to find the population standard deviation and also variance. There will be the direct formula. So guys, if the data is population, you use population, standard deviation, and variance. If the data is sample, means you have to find the sample, standard deviation, and variance. Don't forget the symbol. For the population variance, we use small sigma square, while for the sample, we use S square. To find population standard deviation, simply equals STDEV dot P, okay, then the data. This is the population standard deviation. To find the population variance, just square the standard deviation. So this one, we square it. 3.583333. Okay. Same with the sample standard deviation, equals STDEV dot S, okay, open bracket, the data, close bracket. Okay. Well, for the sample variance, it will be equals sample standard deviation, we square this. 4 point. So, is it easy, right, to find using the Microsoft Excel? Okay, you have found the standard deviation and also variance. What does it mean? If the data has higher standard deviation or variance compared to the other, it means that data is more risky, because it shows high dispersion and high variability.